Hi, Chanchira here from Dynaway, and today I prepared something special for you. Thanks to Maintenance Disrupted, I got the chance to interview Ronan O'Sullivan from SSE. SSE is a multinational energy company headquartered in Perth, Scotland, and Ronan is a maintenance asset integrity engineer who works for SSE to ensure generating plant infrastructure is operated and maintained to maximize safety, reliability, and efficiency. I interviewed him about condition monitoring that he recently implemented in his maintenance organization. And I hope that this interview can inspire some of Dynaway's followers and give them courage to consider implementing condition monitoring or other advanced maintenance solutions into their operations. In the description under this video or above the playhead, you can see the timeline with time steps so you can jump between the topics that we discussed. I hope that you enjoy it and you find it useful.
All right, so I'll just do like a introduction of how and why this is happening.
Yeah, sure.
For Dynaway's followers, this is a bit different than what we usually post. I decided to talk to Ronan O'Sullivan today from SSE. Do I get it right?
That's true,
yeah. And the reason that I'm talking to him today is because I want to learn something about condition monitoring. I saw his post or his comment on LinkedIn on a page called Maintenance Disrupted about condition monitoring. He posted a story about a condition monitoring implementation. So I reached out to him, and that's where we are today. So my idea of this is that first I would like to hear some shortly about you and about SSE. What are your responsibilities? What does SSE do in general? And then we would jump into the condition monitoring. I'd like to talk about how does your maintenance department work, and how was the situation before you decided to implement it? What was the impetus? Like what was the leading force for the implementation? I'm especially interested in hearing about if there was some resistance to the implementation, because from my little knowledge about the topic, I know that maintenance managers usually are hesitant to jump into this kind of projects, or they face resistance from the managers or coworkers.
Yeah.
And then how did you implement it, and what are the outcomes that you expect? So
yeah, sure. Yeah.
So can we start with the introduction about you? And
yeah, sure. Yeah. So Ronan O'Sullivan. Say I'm working for SSE at the moment. So I am based in the southeast of Ireland. So SSE have a power station down in that direction, which is a CCGT power station. It was built around 6-7 years ago now, so I was there from the start. We kind of got bought in as part of the construction team, so we've kind of been building up our maintenance program, you could say, for the last 5-6 years. So I'm an engineer there, so kind of on the asset integrity side. So look at a lot of stuff really, and kind of look broadly across the plant and seeing where things need to be done, with a particular focus then on the maintenance side of things. The company themselves are primarily based in the UK and Ireland, with about say 10 or 11 thermal plants on the go. Primarily the business is moving more towards renewable energy, but looking to try and have a kind of a thermal side as well, with backup to support that renewable energy, I suppose, for intermittency and stuff like that. And I suppose over time, hopefully, to even reduce the carbon footprint of that thermal side of the business. So with carbon capture and stuff, we're starting to look into that and go in that direction really. So we'll see what happens, I guess, in the next 10 years. So it's exciting times, I suppose, considering thermal isn't maybe the most glamorous side of the business these days since renewables has come along, but there's good plans in place to try and prolong it, I guess, and turn it from a potentially dirty industry to a relatively clean one.
So I read on the website that it's you're generating wind energy. Now I hear that you're generating also thermal energy. Is that it?
Yeah. So wind is primarily the renewables focus, let's say, and then I think we
So thermal isn't considered renewable.
no, so it's gas. So we're generally all gas-fired
Okay.
power stations now. So all the coal stations are gone. So it's only pretty much gas left on the thermal side. So it's just two different sides of the business, really. But as I say, there's some projects in the pipeline for potentially hydrogen fired turbines, or as well as adding carbon capture and storage as well. So there's some interesting things in the pipeline. Yeah.
So what kind of machines are we talking about? That what is the most expensive assets that you maintain?
Well, I suppose the gas turbines, obviously the main centerline equipment would be your big money items, I guess. But I suppose, luckily enough, they kind of, I wouldn't say they look after themselves exactly, but they tend to come with kind of fairly robust, maintenance contracts around them and stuff like that. So they're kind of the things that, when you buy the machine, they kind of come ready, packaged with all the maintenance level of thinking kind of done already, for the major stuff anyway. And then it's what we call the balance of plant, the stuff that fits around that, like your boilers and all your various water systems and chemical systems and all that kind of stuff that fit in around that to make it all sing and dance, basically. So that's probably, you could argue it's maybe like a 50-50 split in terms of cost of a new power station, maybe, between your main turbines and stuff, and then the rest, basically.
Okay. So half is the main turbine, as you were talking, and the rest is supporting
the process. Yeah, exactly.
Okay.
Yeah. So,
I'm trying to wrap my head around it a little bit. What are we talking about?
What we have is everything is one center line. So your gas turbine and steam turbines and your generator are all on one shaft, pretty much. And then, so the waste heat off your gas turbine goes into your HRSG, which then generates the steam and comes back into your steam turbine. So as I say, we're either pretty much on or we're off. Some plants are different, and you can have a gas turbine separate to your steam turbine, so you can run your gas turbine on its own and then add your steam turbine if you need it, but we can't. So we're just all one. Effectively, we run as one machine, but we can obviously vary load then, so we can go up or down from max load to min load, and wherever we are needed on the day.
Okay. So about the maintenance operation. So you said that it kind of comes when you purchase the assets.
Obviously, it depends on probably who you're buying the asset off, but our particular vendor, say something was built in from day one into a contract to say, look, at particular intervals the machine will stop. You'll have an outage, and you will maintain certain parts of it, let's say, and refurbish them and do whatever you need to do. And that's kind of set out at the start, so every so often, normally so many run hours, the machine will stop. You'll overhaul it, or you'll do a certain amount of it at this point. Then you'll run again, and then you'll do a bit more. Then you'll run again, you do a bit more, and then eventually, maybe after a 6 or 8 year cycle or something like that, it'll be kind of, you start all over again. Then the machine has kind of been fully overhauled from start to finish, and then you start again with another 6 or 8 year cycle. So a lot of that is kind of, as I say, built in from day one. But I say then it's the rest, the stuff that fits in around that is the bit that doesn't come with a lot of instruction, and you kind of have to determine your own maintenance program around that type of stuff.
Okay, so is it you are performing the maintenance internally, or is it someone from you said you have a contract with the vendor?
Yeah, so A mixture. So like how we have quite a small maintenance team. So we've only maybe got around a team of 20-ish, let's say, in total. So that's including engineers and some technicians. So we've got about 5 or 6 technicians, and the rest would be kind of engineering staff. So a lot of the day-to-day kind of preventative maintenance type checks, lubrication, all that kind of stuff we would do in-house with our own people. And then the kind of heavy duty type maintenance will be done with contractors normally. So so we'd have our kind of some day-to-day contractors who'd be around all the time, and then you've other, like those for these big overhauls, an influx of bodies would come for a couple of weeks and then they'd be gone again. So it's varied.
So I guess that was a pretty nice introduction, and now we can start talking about the condition monitoring. So was there something wrong that like in the maintenance operations, or like a lot of downtime, or what was happening that led you to this?
Yeah, not necessarily, but I suppose just really kind of moving with the times and moving with best practice. So when we set up our program initially, we would have kind of set up a lot of visual type PMs for our own guys to do, and I guess that wasn't such a bad thing, I suppose, because it got people used to the equipment for the first couple of years, and they got to see everything up close, and we got to kind of learn and see how things were performing over time. But I suppose after a couple of years, let's say, we kind of realized maybe we could maybe get a bit more out of this by kind of doing a bit more condition monitoring and getting a bit more kind of hard data really to influence our decisions. So we started off on the journey really and looking into it, what was available out there and who was doing what in our locality and things like that. And I suppose with all of these things, you kind of they take time really to figure out what's what. So about 2 years ago, maybe it kind of landed with me to start looking into this properly and seeing what was out there and seeing what we could do. So we just got in touch with a few companies who were kind of operating in our area and said, well, what can you offer? But one of the issues we kind of kept running into was obviously in a power station, things run best when they just continuously run and you're not swapping around and chopping and changing equipment over and stuff like that. And especially operators and stuff would be kind of nervous about changing over certain equipment. So if you've just got somebody turning up wanting to take some readings on a particular day, a lot of the equipment may not actually be running and are operating, so they might just miss out on quite a lot of information. And if a lot of your equipment, which we have, is kind of redundancy equipment, then actually they might only be getting a quarter or a third maybe of the equipment that we'd actually like them to be monitoring, let's say, on any given time. So it became a bit of a stumbling block for a while, that kind of put us off a little bit. Just what was being offered didn't seem to kind of quite match what we, how the plant operated really. So so we kind of parked it for a little while, and then we came back to it. And actually we got in touch with a company or two who were, your typical kind of Bluetooth type sensor now were kind of coming around and coming on the market and being developed. And so we got a few companies in to discuss that, and it seemed like the right solution for us, that you could mount these sensors on. We don't have Wi-Fi in the plant or anything like that, so we're quite basic. So, but you could put these sensors on, they take the readings themselves automatically at whatever, every 12 hours, 6 hours, 24 hours, whatever you choose. And then like that, you can get your guy to come around and he'll download those readings once a month, let's say. And if equipment has been changed over and that in between, at least you know that the sensors had a good chance of possibly picking up a reading off of that, and you're getting some good information, So that's kind of, in the end, that was the system we decided to go with. It seemed to suit us best in terms of, as I said, getting a good spread across all your equipment and getting a good spread across even the redundant equipment that may only run occasionally and like that. You're not putting pressure on operators to change over equipment just so somebody can take a vibration measurement or something like that. Things will be getting changed over naturally. Maybe as the machine comes off and comes back on, things will get changed over. So you were capturing all of that information without putting undue pressure on people to do it at a particular date and time.
Let me check with you if I get that right. So when you were changing equipment, like when the equipment had to be changed out, you started implementing the sensors on these changed assets?
No, it's more like, say, if you want to change from pump A to pump B,
Yep.
Sometimes, let's say, operators will be nervous about doing that, because if pump B doesn't start, and then pump A, and then it tries to switch back to pump A, and pump A doesn't start, you could end up tripping your whole power station, let's say. So
Okay.
operators will be nervous about changing from your A to B or B to C or whatever. So what we wanted was a system where it never really mattered when that changeover was done. So sometimes now, when the plant just comes off, say the grid doesn't need us, the plant would come off, and we actually, as well as this, we kind of developed a program of changeovers, so that we make sure that the equipment is getting rotated frequently. So maybe every 6 to 8 weeks, we try and get all the equipment to operate a little bit, even if it's only for one shift or a couple of hours. At least it's not sitting there for long periods of time, and potentially developing other failures. And again, you're not, you start to lose confidence then if something hasn't run for a long time. Are you confident that when you do need it, it actually will run and will start? So so there was kind of two things. We bought in the condition monitoring equipment, but we also developed a kind of a strategy around changing equipment over, making sure everything is getting run fairly frequently. We kind of picked it roughly around an 8 week kind of period, where we kind of said, well, look, in every 8 week period, we'll try and give all the equipment some level of running, and that way then we know that with the sensors that we've installed in various places, we should at least get some data from those sensors at least every 2 months, if not before that.
So, and you said that it was an external company that helped you install these sensors.
Yes.
So how
did that work?
how did you choose them? And how did it work?
Yeah, there was probably about 4 or 5 potential companies, let's say, who we could have went to, but some of them were very much just they would come to your site on a given day with their handheld unit and go from pump to pump or whatever, let's say, taking readings, and whatever they get, and what's not running, you don't get that month. So that, as I said, that's wasn't something that really suited us, because of a good bit of our equipment would be redundant equipment, and we didn't want to be putting pressure on people to change over equipment just because somebody arrived on a particular day to take the reading.
Okay.
So we kind of ruled them out as being not suitable, and then so that got us down to maybe 2 or 3 options, I think. Again, just looking into the kind of the specifications of some of the equipment, we just thought there was better options out there, so maybe that left us down with 2. And in the end, the company we went with, I suppose, just, yes, they did this. They had the sensors, they had the equipment, much the same as many other companies doing the same thing, but they also had a few extra strings to their bow. Let's say they had a kind of a structural division as well that looked at kind of more building structures and potential vibration issues and stuff like that around those. So in the end, we just went with a company that we thought could give us probably the broadest service that was available, I suppose. And so that was kind of really, that was it. And I suppose obviously there was they were competitive as well cost-wise, so it just made sense to go with them in the end. And that's what we did.
So they came.
Yeah,
they
so
came in. They yep.
Yeah, so I suppose how it worked then is we purchased a number of sensors. I think it was about 75, and then they came in. They fitted them to the equipment that we'd identified that we wanted to monitor. And that was it really. A couple of days and you're done and everything is set up and you're ready to go. And then how it works then after that is every month they just come around with a tablet and they can just go from sensor to sensor and just download the readings to the tablet. Then they can go up and put that onto their system, and then they do the analysis off-site, and we get a report then to say, everything's healthy, or these ones might need attention, or there's something occurring maybe with these ones that you need to do something with or whatever. So, but again, we're limited, I suppose. Again, we don't, as I said, we don't have Wi-Fi in and around the building or the various buildings. So that's kind of why we still require somebody to come around and actually download everything and take it away. Whereas, if you're a bit more advanced, you can set up gateways and things like that they'll actually, the sensors will just talk to the gateway, and the gateway will send the information off automatically at a given frequency. So there's scope there for it being a bit more automated, let's say.
So can I ask about how did, I mean, everything was okay, right, before you started implementing it. So what did your colleagues and your managers say? Why do you need to? Yeah. What did they say? I don't want to put words in your mouth.
Yeah. So I suppose luckily enough, our manager is quite supportive of initiatives like this, I guess. As I say, it was something we probably identified early on that was something we needed. But as I say, it just took us a few years to probably get the right solution and put a focus on it. So I suppose it really comes down to managing risk and things like that, and to reduce your risk as much as possible. The more information you have, the better information you have, the better it is for everyone. So primarily that was it. It gave us what it gives us. Apart from, it allows us to have a higher level of comfort, you could say, to say that how healthy is our equipment? Well, if we're just doing our visual inspections, you could kind of say, well, we think it's okay, it looks okay, it sounds okay, it feels okay. Whereas with the vibration information, and they also do temperature as well, you're getting a continuous kind of more in-depth look at your equipment, really, to say, yeah, well, we know it's okay. We got the report a week ago, and everything is healthy. So it gives you a greater level of comfort. But obviously it has a lot of knock-on effects. So I suppose a lot of people will kind of say, well, what's the return? And how do you know this? You spend some money on this. What's your return on it? And sometimes that's very hard to quantify, because if you don't get a lot of failures, it's easy to dismiss as being, well, that was maybe a waste or whatever. But it does have a lot of knock-on effects. While you're, and that was the post you saw on Maintenance Disrupted, was somebody who's installed this equipment, and now you're sitting around, you're waiting for a failure to justify why you did it in the first place. So I suppose you could say that we're maybe in that same position. But I suppose, yeah, to be fair, you could say, well, it's actually a massive compliment, really, to the technicians that we do have. Obviously, they were doing these visual inspections, but we also do have, say, a weekly lubrication program as well. So it just goes to show that the technicians that we have, who didn't have any ultrasound lubrication tools or anything like that, we were doing probably a lot of the right things, to be fair, with very little tools available to us. So that's a good compliment, I guess. But But I suppose now that we have this, it's I suppose you're moving up that P2F curve from your preventative maintenance up to your kind of predictive maintenance. So your ability now to detect failures is going to come in a lot sooner, hopefully. Which, especially in a power station environment, you're a lot of the time you're trying to operate from outage to outage, which could be maybe some people maybe every year, some people maybe every 18 months, 2 years maybe, and ideally you're trying to nurse the equipment along from outage to outage so that you have to take as little downtime as possible in between that time. So I suppose the earlier you can detect any potential failure means you have the ability to possibly nurse that equipment along, get it, switch over maybe and use one of your other redundant ones that is healthier, and you can keep that one in reserve if you really, really need it. But if you don't really need it, then just leave it there, and you might get to that outage period where you can plan better, you can budget better. It's maybe safer in terms of getting isolations on the plant and stuff like that. You're not trying to isolate a particular piece of equipment with other live plant around it. So it has a lot of kind of knock-on effects like that. Obviously, a lot of the visual PMs that our technicians were doing are no longer really needed, because let's just say, for example, if you had, say, some rough numbers, let's say, so if you had 75 assets that you wanted to monitor, and let's say you were maybe doing a visual inspection on those maybe once a quarter, that's what, like, that's nearly 300 PMs a year, something like that you're doing, and that's 300 PMs that need to be, well, we're still using a paper-based system, so they have to be printed off, they have to be planned, they have to be scheduled. Your technician has to go out, sign them back, your permit to work system, so things like that. So, and if he's taking maybe, or he or she is taking maybe 45 minutes per PM to do, by the time they sign it out, get down to the job, get their permit, go do their visual inspection, come back, sign back off the card, re-enter it back into your CMMS system. We're talking well over 200 hours a year for those PMs and those 75 assets. Whereas when you go to the condition monitoring system, let's say, you're still covering your 75 assets. The guy who comes around to do them is probably doing it once a month. So you're probably going to, you're going from, so you're only talking 12 PMs a year. Now he's probably taking a full day to go around to that. But so it's a massive saving in terms of your technician time, who can then obviously go off and go and do other corrective work and maybe address some of the issues that weren't getting done before because the PMs were probably being prioritized, or what else could they be doing? I suppose, like, if you have any other kind of maintenance initiatives that, sometimes it's very hard, like, you'd like a technician to be on that, involved in those initiatives, and get, coming in and having more the strategic discussions, but often they're just not available because they're just doing, 30, 40 PMs a week or whatever. So yeah, it's definitely, gonna bring big benefits outside of the preventing the failure type ones that we're all waiting for, and trying to show how the equipment really works. It brings lots of other benefits really to the overall program. Yeah.
So how long has it been since it's been live?
We probably have it live now about 6 months only, I'd say. So it's not too long, but as I say, the equipment has probably been running for a good maybe 6 years, fairly continuously. So it's a good sign. And I suppose that if you've been looking after it and like that, you've got your good kind of lubrication program in place, you'd hope that you wouldn't have seen too many failures in that time frame anyway. But probably from now on, you could say 5, 6, 7, 8 years down the line, it would probably be a good time to start looking at it, because you could probably start maybe expecting some failures between now and 10, 12, 14 years, let's say. So we think we probably got around to it at a fairly good time, to be honest.
That's really like looking at really long time frames to see specific results with how it's affecting the downtime and like the reduction in number of work orders and
exactly exactly. And it's a massive thing for us to know, even for budgeting. So we're trying to budget, say, this year for an outage that might happen next year. And I suppose without the data, without knowing exactly what state your equipment is in, you might always be over budgeting, maybe anticipating that you might have to overhaul something or replace a motor or whatever, or under budgeting. You think, fine, look, we'll have some bearings, let's say, we'll get the bearings, some labor, and it'll be fine. But actually, if something fails and you get a lot of secondary damage, especially in a motor, and it has to go off and be rewound or something, you could have a big deficit in your budget that you've left yourself completely short on.
Like, is there someone who you wouldn't recommend this to? Some maintenance manager who would say, I mean, it's okay. The maintenance guys, they just they get it. They understand what's happening.
Yeah.
Maybe it's not necessary.
I suppose it depends on the size of your business, I guess, and what your because it's not cheap. You do have to spend some money, but generally no. Like, I think if you're in a process plant and things like your availability and your equipment uptime, and if you've got very little redundancy, if you've got a lot of critical equipment, stuff like that, I think it's the earlier that something is not quite right, the better. And as I say, yes, it might even seem expensive on a monthly basis or an annual basis that you have this in place. But as you know, if you've got some pretty expensive bit of equipment and it goes down, it's going to look like small money, really, when you have to pay for that repair. And I suppose it's not that you wouldn't have had to pay for the repair to begin with. So if a bearing was going to fail or something, it was going to have to be replaced regardless. The condition monitoring wasn't going to probably prevent that. But I suppose what it can do, as I said, it's prevent maybe any secondary damage where, fine, the bearings are gone, you replace them, maybe it costs you, I don't know, €1,000 or €2,000 or something like that. Whereas if you don't pick it up and it fails fairly catastrophically, and you get a lot of secondary damage, I don't know, and your motor is either wrote off or you need to do like a rewind or something like that, then you're probably into the maybe heading for €10,000 or €15,000, depending on what the equipment is, plus potential any production loss or anything like that you might be suffering as well, So it's it would be it's hard to think of where it wouldn't be a good idea. I'll put it that way.
You were talking about how maybe if there is implemented condition monitoring, that there is not a need for as many PMs.
Mm-hmm.
So has there been a change in that? Like, have you reduced the number of work orders you send out to the guys?
Yeah, we've made a fairly significant change ourselves, I suppose. And it's not, and I suppose some people just have, will equate work orders with work, with value, I suppose, and work being done. And when you take those work orders away, there can be the perception that all of a sudden you're not doing anything, that you're not doing work or whatever. And some people can struggle to get their head around that. But actually, our justification is that we're actually doing more. We're actually doing more checking than we were before, only that we're doing it with less paperwork. So as I said, maybe before, like a typical PM program might be sending somebody out to do a visual on a pump or something, or a fan once a quarter, let's say. So that's once every 3 months. It's getting a bit of a look. What we're actually doing is we're actually having a look every month. So it's actually, getting far more of an inspection, because obviously when the guys are there, they're not just purely downloading the data and walking off. While they're waiting maybe a minute or so to capture that data, they're obviously looking around. So you're looking for your mechanical seal leaks or something like that, or your flange leaks and things of that nature. Our lubrication PM is probably the most important one, which we didn't alter. So the guys still go out every week on their lubrication PM, which again goes to many of the same assets, maybe not as frequently. So depending on what they are, but so that's another layer of checking on the same equipment. Another thing that's happening, of course, is your operators are obviously out there as well, and especially in a power station, your operators would tend to be fairly technical kind of people anyway. So they're also doing their daily, probably every shift, they're going around from area to area looking at the same equipment. So between everybody, you're doing lots and lots of visual checking. So anything obvious, let's say like your leaks or seal leaks and things like that, should generally be picked up by those. Your lubrication is taken care of by your lubrication PM, and I say we work with another good company to put that in place, and I say it seems to be working because we haven't had many failures. But like that, if it does need adjusting, we feed back to them and say, well, look, what do you think about this? They're kind of a lubrication expert. They advise on what we should and shouldn't be doing and how often we should be doing it, and then we just kind of go and implement it. So actually, by bringing this in, the perception might be that you've gotten rid of loads of work orders, so therefore you're doing less. But actually, we're doing more, and we're getting better information. We're getting better data. We can now detect failures potentially a lot earlier than the guy who was doing the visual. Like if you're doing a visual, you're going to be waiting really to hear the obvious noise or the obvious vibration that you can feel with your hand, basically, or things like that. Whereas the sensors are picking that up way before anybody would probably notice with a visual inspection. So
right. That's a pretty good argument, I think.
Yeah.
And maybe a good point to end on. Do you have something else that we didn't talk about?
No, I suppose only that. I suppose it's really only one part of the condition monitoring story. And there's lots of other bits to it that we don't currently have, maybe that we'd like to have, but we don't yet. But it's
so. What's like what would be like the next step if you wanted to take it further?
I suppose at a basic level, so we do a bit of thermal imaging as well. We do that primarily with our electrical equipment, so especially in panels. We do the motors as well. So that's, I suppose, another condition monitoring string to our bow. So something we don't do a lot of is monitoring on valves and that, so passing valves, steam traps and stuff like that. So that's probably something we could look to do in the future. And then of course it's the potential there from just the general digitization and all the talk that's happening around that at the moment, and seems like the sky is the limit really, in terms of what you could do. From a lot of companies are kind of trying to maximize their digitization in general in all parts of their business, and I suppose that the maintenance side of things shouldn't be any different. So I've seen some good examples of that out there, but it's not with us yet anyway. But we'll see.
So digitization, you mean the general work orders, or?
Yeah.
Right.
I suppose going to so instead of getting rid of your paperwork and getting down to going out with a tablet, things like that, to the probably the extreme end of the scale, which is like your prescribed maintenance. So where I suppose my understanding is of it, where it's pretty much you would almost have very little or almost no PMs being generated every week. It's primarily the machine is self-monitoring, or it's being monitored by an algorithm of some description that's flagging potential issues like that maybe long before they become serious issues. And like that, you're going out and you're targeting potential problem areas rather than targeting things that might have absolutely nothing really wrong with them. So yeah, there's a lot of that going on in terms of even having information on the job. So you're having your drawings, your manuals, all that kind of stuff digitally in your hand possibly, or coming up on your safety glasses or whatever's going on. Yeah, so like that's stuff that's out there. It's just it's probably just not that commonplace yet, but it's certainly heading in that direction.
Yeah, that's what we do in Dynaway. We develop this kind of information for the maintenance technicians on their phone. When they arrive at the assets, you have information about the work order, like the work order on the tablet. You can access the information about the asset and also everything, but only integrated into Microsoft Microsoft ERPs. So that's what we do.
Yeah, exactly. Yeah. So and I know certain parts of our especially on the renewables side, that's a lot of the stuff that they're looking into at the moment. Obviously, especially with wind farms and whatever, it's a lot of remote kind of working, and you're away from the kind of the central hub of your IT systems and plant information offices and stuff like that. So to be able to bring that to the individual when and where they need it will be is a huge plus.
Mm-hmm. Thank you for your time. I definitely learned something today.
Much appreciated.
I'll cut this into something and get back to you when I'm finished.
Cool. Good stuff. All right. Thanks, Carl.
Yep.
We'll speak to you again.
Thank you, Ronan. See you.